Lesson 2, adding, subtracting, and multiplying radicals. So again, for the most part, you guys have done things like this before. There's going to be a little bit new. First thing we need to look at, though, is something called like terms. You're going to hear this a lot. So we need to figure out what I mean by like terms. So right off the bat, if I look at these two, would you would you think they were like terms? They are not. There's nothing alike in those, right? And these ones are. So you can kind of tell what we're talking about here is that the m's are the same. So that's what makes those like terms. So this first one, 2m plus 3n, well, that's just oh, still 2m plus 3n. I wasn't able to combine those things, right? They have to stay that way. But this top one, if I have 2m plus 3m, what you're able to do is take the coefficients out front, 2 and 3, and just add them. And then there's going to be that many m's. So there's 2m plus 3m's. That's going to be, well, there's now 5m's. So that's what I mean by like terms. If you look at different situations here, so 4 root 6 and 3, they are not like terms. The second term has no radical at all. There needs to be a radical. So just like here, how these were m's, we're going to have radicals that need to be the same. So if you look at the next one here, 4 root 6 and 3 root 2, they're still not alike because they're not the same. This is the same. This is similar to up here where you had like 2 times m and plus 3 times n. Those two are different things, right? So they're not like. If you had 4 square root 6 times 3 cube root 6, they're still not alike. This is different than this. They are not like terms. And then finally, like terms, yeah, this is it. 4 root 6 and 3 root 6. That's pretty much like, really similar as saying 4m plus 3m, right? But instead of an m, we have a root 6. So those are like terms. And what you could end up doing if you were adding those things, we could say 4 root 6 plus 3 root 6. Just like before, we can say, well, that's just going to be 7 root 6. So that's why like terms are helpful, is that we can simplify things. You'll see in a minute here. So like if you look at A here, so if we're adding things that have like terms, well, all you're doing, you could really just look at square root 11 in each one of those things, and they're all alike, right? They're the same thing. So all we really need to do is take the numbers out front, the 3, the positive 6, and the negative 2, and just add them together. This would be 3 plus 6 minus 2 gives you 7. And that's just kind of what's been written here too, right? And then that's followed by what the like term was, that square root 11. You can see, I'll let you guys go ahead. Well, actually, no, I'm sorry. I'm going to do B. There's a new thing here. You might look at this one to begin with and say, well, they're not like terms, can't do nothing. I'm kind of stuck where I'm at. But maybe not, and probably not with the questions you're going to have. What we can do, if you look closely at 4 times square root 8, remember from our last lesson that you are able to split that square root 8 up into two things. And we're going to split it up into 4 times 2, because 4 is a perfect square, so I can take it outside the square root. So if I do that, and the other one, 32, I can split that up into 16 times 2. And if you do that, we know what the square root of 4 is, and we know what the square root of 16 is, so we can move them outside of their square root symbols. And if we do that down here now, that 4 moved out, it's now a 2, and that's being multiplied by the 4 that's already out there. And similar things happening to the other term there. You end up with 8 times root 2 minus 20 times root 2. Now these are like terms. Now they have something in common. Now all I have to do is go 8 minus 20 and end up with negative 12 times root 2. And you can do something similar with cube roots as well, using the same type of method that you guys did last lesson. Okay, so your turn. Go ahead and see if you can simplify this expression on your own. So go ahead and try that. Pause the video now. Okay, so if you kind of look at what I've got going on here so far, in green here, I've just kind of split these up just so you can see what each term in a different color here. I've split out 27 as 9 times 3. And now I know what the square root of 9 is. It's 3, so I can write that out here. So that's going to be 5 times the 3 that comes out. Maybe I'll do that in green too. 5 times that 3 that's out there now, times root 3, minus the square root of 16 is 4, so I've got 2 times the 4 that I just brought out, and I have a 2 still under there, plus 3, oh, I forgot to write in different colors, oh well, times 6, because the square root of 36 is 6, times the 2 that's, or times the square root of 2 that's still in there, minus 2 times, I'm going to bring out a 4, and now I've got square root of 3. If you just multiply the numbers that are out front now, we've got 15 root 3 minus 8 root 2 plus 18 root 2 minus 8 root 3. Now we just got to make sure, okay, what are our like terms? Well, this one is alike this one. This one is alike this one. All right, and then just add the numbers out front. So if I look at my blue ones I've underlined there, we're going to have 15 minus 8, so that's 7 root 3. And then the red ones I've got there, I've got 8, or negative 8 plus 18, so that's going to be negative 10, and then root 2. And then that's as far as we could go, so that's what an answer might look like with these type of questions. Okay, moving on. Okay, the old perimeter question. So perimeter, remember, means the distance all the way around the outside. So how far it is from there all the way around. So what we're going to be doing is adding that. So on the bottom here, we've got 2 root 6 plus root 3 is the length of that side. 3 root 3 minus 2 is the length of that side. So I need to add 2 root 6 plus 3, that's the bottom. And then I'm going to add that again because that's the same as the top, right? I have 2 of those, so I'm going to add that again. And then I have 2 of the other sides of this side. So that and that again. So if you want to figure out what the perimeter was, you just add all of that together. So what we're really doing when we're adding those, we're just collecting like terms. So if you do that, you end up seeing, okay, my root 6's, if you underline those, so root 6, and that's it. So 2 plus 2 is 4 root 6, so we're good there. If I look at my root 3's, in green maybe, so root 3, root 3, root 3, and root 3. So remember, this is like having a 1 out front. So I've got 1 plus 1 plus 3, so that's 5, plus 3. So that's going to be 8 root 3. This is a mistake on here. Can you guys go ahead and change this to an 8 root 3? That shouldn't be 6. And then the last one, we're just looking at our numbers. Those are also like, you can think about it as being like terms. They're just numbers now. So take the negative 2 minus 2. We're going to have negative 4. Oh, I see what, never mind. Sorry, that wasn't a mistake. It was just split up. So that's still right. So the 2 root 3, that came from that one and that one. And then 6 root 3 was that one and that one. And then in the end, it's 8 root 3 minus 4. Sorry about that. Okay, your turn. Determine the exact measurement of the perimeter of a rectangle having sides of that and that. So a similar type of question. So I'll get you guys to go ahead and pause the video and finish this one now. Okay, so there we are to start. I've just kind of wrote each side in a different color of a rectangle. First off, though, we are going to need to break up a few of these things into a lower mixed radical, like this one. I can write this as a different mixed radical with a lower number under the radical. Same with that one, and that one, and that one. So let's go ahead and do that first. So I'm just going to rewrite the whole thing again. I know this is kind of time consuming, but 4 times square root 5 minus, this becomes 6 root 3. You can go ahead and try that one too to figure out, see if you know where I got that from. And then plus 4 root 5 minus, this is the same, so minus 6 root 3 plus 125. This is going to be Oh, that was weird. Going to be 5 root 5. If you break this up into 25 times 5 and then take it out, plus 2 root 3 plus 5 root 5 plus 2 root 3. All right, I know that seemed like a lot of work, right? Now, because there's so many things, what I would probably recommend doing is kind of underlining or circling or something like that, all the ones that you need to collect. So we've got, in blue, I'm going to do my root 5s. So that one, that one, that one, and that one. Okay. Now I'm going to rewrite that with just adding the numbers out front. So we got 4 plus 4 plus 5 plus 5. So I've got 18 root 5. Now if I look at the root 3's, maybe in green, get that one, that one, that one, and that one. So now I've got negative 6 minus 6, so I'm at negative 12. And then plus 2, so I'm at 10. And then plus 2 more, or sorry, negative 10. Plus 2 more, I'm at negative 8. So minus 8 root 3. And that's pretty much it. That's the gist of it. One thing, part of your guys' curriculum is being able to order radicals. Not really too concerned about it. What I would do, just because it is something that you're expected to be able to do though, I would put this right in your calculator and then order them. So what I mean by that is literally, I'll show you how to put in your calculator if you don't know. So let's do the bottom one here. So I would go, well, this first number right here, I would write that in my calculator. I go 2 times, and then square root 3. And then I'd write that down, so 3.46. And I'd rewrite this next number, so cube root 10. So then the cube root on this calculator anyway, if you have a different TI version, it'll be different. But you can see like in blue, there's like the n and then over square root x. That's the one you want. So control that one. And now you can actually just put a 3 in there. So you just go 3, arrow over, and then 10. And then 2.15. And then square root of 121. $11. And then 3 times 4th root of 15. So 4 goes there. 15. 5.9. Okay, so now this becomes pretty easy, right? You guys should be able to order these ones. Just decimal numbers, right? Okay. So I'm going to end that video there. I'll pick up with multiplying in the next video. And then our homework is going to be on both. So that's going to be it for that video.